Hello everyone, this is Deepak Joshi, and today we are going to solve another problem statement from LeetCode, that is foursome. Uh, yes. Okay, we have done twosome and we have skipped threesome. I don't know the reason. But yeah, for now we have skipped threesome, and now we are doing foursome. Okay. Sounds interesting. Please, uh, leave your dirty mind out of this video. I don't know why my mind is thinking in that way, but yeah, like the question statement states that we have given an vector, and we need to find four elements which adds up to a particular target sum. How we are going to approach this particular problem statement? uh, like it is easy to approach this particular problem statement from a brute force point of view. What do I mean by brute force point of view? We can have four for loop, one inside another, and on the basis of that, we can compare. We can compare. We not compare. We can add all the four elements present in the for loops elements, and then compare it to the target sum. If that is equals to the target sum, no issues. We are going to add it to the stack or something like that to have unique pairs, as well as we need to sort the output. Like, let me show you the example. Here is an example of given nums, and in this particular given example, what we need to do is we need to find four elements which sums up to zero. Okay, how we are going to approach that? By brute force method, what I'm going to do is I am going to store my initial vector into a stack. Why? Why did I say it stack? No. I need to store unique entries of the vector elements. So it should be a set, not a stack. Okay, I'm going to have a stack of vector which is going to store four element at a time, right? And yeah, that will be okay, that will be fine. I need to sort that particular vector before storing it into the stack, so that I can have a sorted vector array in my stack. Yeah, like I can do that. I think we can do that, but how we are going to do that? We can have a stack. Then we are going to have four loops in which we are going to calculate sum. If the sum is equals to target, we are going to store all the four elements into a vector. We are going to sort that vector, and then going to store that vector into the set. And eventually, after all the for loop ends, what we are going to do is we have to return a vector of vector. Then we are going to create a vector of vector and store all the vectors of the set into the main answer. This is our brute force approach for this particular problem statement, that is foursome. Yeah, guys, let's code this. Okay. And like how we are going to code this is I am calculating the size of this particular given array, and then we need to have a set of vector as well. So okay. It will be vector of int, right? Let us call it as st. Yes, this will be our set. All right, and then we have to iterate over all the elements four times. So we are going to store, like we are going to start from for int I equals to 0, I is less than n, I plus, and then for int j equals to I plus 1, and j is less than n, and j plus plus. Alrighty, and then we are going to have int k equals to j plus 1, k is less than n, and k plus plus. And honestly, I uh, am afraid to use for loops, because the time complexity will be O of n raised to the power 4, and the space complexity will be O of n square plus n. Or yes, like but for now, I'll be fine using four for loops. K plus 1, L is less than n, and L plus plus. Here is our four loops that we are going to take care of. Now what we need to do is we have to add uh, the variables. For now, I am adding n nums of I plus nums of j. Yes, and then I am adding sum plus equals to nums of k. Why, Deepak? Why you are not adding all the nums of I plus j plus k plus l at the same time into the sum because of integer overflow. This can be a potential. This is the potential reason I am adding them separately, and nums of L. Yeah, and then I am going to check like whether my sum is equals to target or not. If that is the case, then what we need to do is we need to create a vector that will contain all the four elements. We'll do that. Let us call that temporary vector. How we calculate, like, okay, this is the method, like this is how I think. I don't remember. Let's google that out if that is not the case. Ijk and then nums of L. Yeah, okay. I have created the temporary vector containing nums of I, nums of j, nums of k, nums of L. Then I need to sort this particular given temporary, not given, created temporary variable, nums dot begin and temp dot nums dot end. As simple as that. Yeah. Yes. And then I need to add this particular temporary vector into my set. How do we add into the set? Is it push? I think it is insert. Nice. We have added our temporary vector to our set. Yes. Yes. So I think we are good to go. And like if after the completion of this, after the completion of all the four for loops, we'll be able to get a set containing unique vectors having four elements which add up to target. Yes, I think I am in the right direction. And yes, after the completion of all the four loops, what do we need to do is we need to return a vector of int. I am creating that and answer, and it will contain set dot all the vectors of set st dot begin, set dot begin, and st dot end. Simple, and I'll return answer. Yeah, like time complexity will be very, very, very high for this particular thing. Uh, so yeah, like let me check whether it is submitted. If I try to submit this, it is definitely going to show me a TLE because I need to do some improvements on this particular thing. How we can do that? I'll show it to you, like how we can do that. Yeah, time limit exceeded. No issues, man. No issues. I was expecting that because yeah, O of n raised to the power 4 complexity is very high for this particular problem statement. We need some improvement in complexity in this particular thing. How we can improve this particular time complexity? I can relate it to the threesome problem statement. I know I have not made a video on that question, but I have solved that. Yeah, I have solved that particular problem statement. And if you guys also have solved that particular problem statement to reduce three loops, what we can do is we can have a hash map or something like that to have the frequency whether target minus sum till two elements is available in our hash map or hash map, I'm sorry, is available in our hash map or not. So similarly here, what we can do is we can have a hash map which will contain all the elements, and we can replace our four for loops with three for loops, and we'll calculate the sum till three for loops, and then simply do target minus sum of three elements, and the fourth value that will be there will check whether the fourth value is in our map or not. If it is there in our hash map, then simply we are going to have four elements, and then we'll add it to the temporary vector, store it into the set. Before sorting it, like we'll create the temporary vector using those four elements, and then store it into the before storing it, we can sort it and then store it into the set. And eventually, after the completion of all the three four loops, we can have our answer vector of vector int and return it from there. Like this can be a potential approach. uh, do I need to repeat that again? I think I should repeat that again. Here what we are doing is we are having our four for loops. I need to reduce its time complexity from O of n raised to the power 4 to O of n raised to the power 3. How we can do that is we can simply have a hash map. Yes, we can simply have a hash set or as well. Like it will, yeah, like instead of having hash map, we can have a hash set. to have unique values in it. Yeah, yeah, nice, nice. We can have a hash set instead of having hash map. Yeah, like we are going to have hash map right now. So we can have a hash map. लाली दिखी मेरे चेहरे पे जैसे ही मेरे को hash map याद आया. Hash map, we can have a hash map, hash set. Why I'm confused between hash set and hash map? We are going to use hash set because we need unique values to check whether we are going to have we are going to have three for loops, and in those three for loops we are going to calculate the sum of all the three elements, and then subtract it from the target, and then check whether the difference target minus sum of all the three elements is there in our hash set or not. If that is there, that means we got all the four elements, and we are going to store it into the vector, going to sort that vector, and then going to store that vector into the set, and then eventually return the 2D vector that it expects from the function. Yeah, like this is we are going to code right now. I think I tried my best to explain it to you. I have zoomed out. No, I think we are good to go with 150% zoomed in. Yeah, let us start coding. Let us start approaching it. Like initially, we'll be storing the size, and then what we can do is we can have a set of vector of int. Yeah, and then what we need to do is we need to have what? We need to have three for loops. Yeah, like for int I equals to 0, I is less than n, guys, I plus plus. For int j equals to I plus 1 and j is less than, oh, I'm sorry, j is less than n, j plus plus. And then we are going to have the frequency or the hash set. We are going to have hash set. We can declare, okay, yeah, like what we can do is let us first iterate over it using our third for loop that will start from j plus 1 and go till up to n and k plus plus. Yeah, simple. Here what we can do is we are going to calculate the sum of long sum till three elements nums of I plus nums of j. Simple as that. And we can add the third element as well, nums of k. Simple. Yeah. And we have to find out the fourth element. The fourth element will be target minus sum. This will be our fourth element, and we are going to check whether it is there in our whether it is there in our hash set or not. Okay, if it is there in our hash set, we are going to simply do our temp and all those sort of things. Yeah, like simple as that. And we are going to add this element uh, to hash set. But the issue is like from where we can get the hash set. Do I need to declare it outside all the for loops, or will it be fine to have hash set just for the third kth loop? From my understanding, we can have the set at both the places, but it will be very um, like tough to empty the set for the iteration. Like for each iteration, we do not need all the like we do not need all the elements before it. Like we need just the elements till which the sum is calculated. So yeah, like what we can do is we can have set just before this particular current for loop, kth for loop. Yeah, like this is what I can think of. We can create the set which will be long log, and let us call it as, oh my god, hash set. Yes, yeah, like this can be done like that. And here what we can do is we can have hash set dot find. I think that is the function. If that is not the case, we're going to google it together. Don't worry about it. Is not equal to hash set dot end. Yeah, when I was uh, very when I was learning DSA, I used to there is a small anecdote time. I used to figure out like what is happening in this particular line. Hash set dot find fourth or anything is not equal to hash dot end. So basically, it returns a like pointer with a is returns a pointer. If it does not point out to end, that means it has iterated over all the set elements and has figured out our fourth element, and it is now not pointing to the end. But if that is the case, like it is, if it is pointing to the end, that means our element is not there in the set. Simple, as simple as that, guys. Yes. Okay, then we are going to do the same thing. Like we are going to create a vector of int that, let us call it as temp, and it will contain nums of I, comma, nums of j, comma, nums of k. Oh, I'm sorry, k, comma, fourth. Yeah, like this will be the temporary. And do I need to sort it? Yes, definitely. Temp dot begin, comma, temp dot end. Yes, and do I need to add it to the set? Definitely, I need to insert it into the set. I'll be inserting it into the set. That is the case, and yeah, like now after iterating, I need to add this particular element to my hash set as well. So I'll be adding it to the hash set nums of k. Yeah, here it is. Okay, and at the end of all the for loops, what do I need to do? Okay, okay, guys. Oh, okay. I did something wrong. No, yeah, like I am at the wrong place. Here it will be. I'll be creating a vector of int. It will be called answer. What it will contain? It will contain st dot begin, because our st contains vector of int, and st dot end. As simple as that. We are going to return answer, answer here. Yeah, this is the case. Let's see. Okay, yeah, okay, okay. I got this. I got this. I think I know what I have done wrong. Okay, okay. It says long to int. Okay, let's do explicit typecasting, guys. Second semester. Yes, yeah, like uh, submitted. Let us submit this and wait. ये जो हंस रही है दुनिया. Okay, it has been submitted successfully. I hope you guys were able to understand what I was trying to explain to you. There is another approach to this particular problem statement that is a little bit tricky, or trickier for me to explain it to you without using pen or paper. I hope you guys should be here so that I can explain it to you using that whiteboard. But yeah, like I am not able to use that right now. I need to figure out some ways so that I can record um, using this whiteboard or something like that. Or I should have a, what is that thing called, where I can write iPad or something like that, where I can write things. Yeah, we'll arrange that. Till then, I can try to explain you that approach. If you guys are not able to understand that approach, please feel free to copy that code, paste it to GPT, and try to ask him like, hey, can you please create a dry run for me, or create could you please explain me this code in a very layman language with some example iteration, edge cases understanding, these type of things. Use GPT maximum. Like it can be your best friend. Like one of my mentor told me that, yeah, GPT can be your best friend for doing non-human task. Like, please do not explain GPT how you're feeling right now. Hey GPT, I'm feeling very sad. It is going to provide you the worst joke ever. Like, please don't do that. I have done that. That's why I'm telling you. Okay. Yes. Like what we can do in this particular approach is, in the third approach, that is the most optimal approach. We want to get rid of the hash set that we are using right now, so as to reduce the space complexity. What we can do is we can use a two pointer approach similar to the two sum thing that we have used. If you have done the three sum problem as well, we can mm, use two pointer in three sum as well. We are going to use four sum in this particular quadruples problem statement. Now, how we are going to use that is a little bit trickier for me to explain you. but I'll try my best to skim you through the code and explain you what is happening. First of all, I am creating or extracting out the size of the array, and then I am creating like what? Uh, yes, we can have our vector of int. Oh my god, yeah, vector of int answer. Okay. Now, do you remember in the previous two approaches we have used a set? We have used a set to store unique values and to store values in sorted manner. What if guys, I can store I sh- instead of uh, instead of storing or sorting that thing uh, on a iterative basis, what if I can sort this particular given nums array right now? Because I do not need to return their indexes. I just need to return what the element. So what we can do is we instead of having that set which is increasing our space complexity, I can directly sort this particular nums array right now here. So I'll be sorting my. There's a reason why I am sorting this. Do you guys able to understand why I am sorting it right now here? Yeah, to reduce the space complexity, because we were using set and we are keeping the track of the elements right here. And I do not want that. That's why I have created vector of int right now and sorted the given nums array right now here. Okay. After sorting, yeah, like okay, I'm sorry why I am typing at the wrong place. Int I equals to 0, I. Okay, this is 0, okay? Less than in I plus plus, guys. Yeah. Uh, okay. Now, what is the case? Like, what can happen is I have sorted the array. There can be multiple similar elements. Let us take this particular example. Yeah. Like, if I sort this 1, 0, minus 1, 0, minus 2, 2. If I sort this, I'll be getting minus 1, I'm sorry, minus 2, minus 1, 0, 0, 1, 2. 0, 0 is repeating twice. Or in the next example, 2, 2, 2, all are sorted and all are duplicate arrays, duplicate elements. I do not want that. Yeah, right now I do not want that I'll be iterating over the duplicate elements. Why do I do not want to keep track? I am sorry, just give me a second so that I can. Yeah. Yeah. Okay. Like my laptop's battery is down. Okay. So why do I do not want that I should iterate over the duplicate arrays? Because I'll be keeping track of the elements using pointers, using 2 pointers or 4 pointers in this particular case. One at the starting, one at the bottom, and two will be moving around here and there. So I do not want that the comparison goes on. If let's say the total sum of four the elements is not equal to a target, then I do not want that I keep on going forward to the same or the element having the same value and checking, hey, the sum of all these guys is equals to target. No, let's move to the same element. No, I do not want that. I want to skip if the element is similar or same or exact or equal. Yes, that is the reason I want to skip all the same elements. I hope I tried my best to explain it to you. So if my I of 0 is equal, if my I or my index is greater than 0, what do I need to do is I need to compare my next element or my current element with my previous element. Whether they are equal, if they are equal, I am going to continue. I do not want that the iteration move forward from here, or the code base should move forward from here. All right. I am going to check like nums of I is equals to nums of I minus 1. If that is the case, please continue, guys. I do not want to move forward with you. Simple. As simple as that, guys. Okay, okay. I think I do not need the space. Okay, it's more readable now. Not readable. Here it is readable. Yes. Sometimes readability is very important. Yeah. And then I am going to have my jth for loop that will start from I plus 1 and j less than n, and yeah, j plus plus. Yes. Okay. Alrighty. I hope I am able to explain you why I am using jth for loop, because I want to uh, keep track of elements I here, then j to the next element till now. And for the jth element, I want to check the same thing, like whether I am using, or whether I am continuing with the same or similar element. If that is the case, please continue. I do not want to sum the similar elements, because the sum of the similar element will be same. So what I can do is, I am sorry, what I can do is, if my j is greater than I plus 1, because I am starting from I plus 1, and if it is greater than I plus 1, and and nums of j is equals to nums of j minus 1. If that is the case, please continue. I do not want you to continue. I do not want that the same thing happens again and again. All right. And now I'll be creating two pointers. One will be starting from j plus 1, and another will be at the end. That will be L, starting from n minus 1. Simple. And I'll start my two pointer approach while k is less than L, and I'll create sum. That will be sum equals to nums of I, and I'll add sum plus equals to nums of j, and I'll copy this, and I'll copy that as well. Nums of k, yay. Nums of L, yay, yay, yay. Okay, okay, okay. Sure. Okay. Now I'll check if sum is equals to target. If that is the case, very easy peasy lemon squeezy. I'll create a vector of n that will be called temp, and I'll store all this nums of I, hey, nums of j, hey, nums of k, hey, and nums of L, hey. Yeah, like this is the case, and we'll simply store this particular vector of temp into the answer. That will be answer dot pushback. Yay! I think I am able to understand. I am able to understand, but do you guys able to understand like what I am doing right here, right now? If that is the case, like if all my four elements are summing up to the target, I have added it to the answer, and I need to move my k forward and my L backward. Simple. And like there is a else if condition as well. I should add if here. If else if, like my sum is less than target, if my sum is less than target, what I can do is, like my current sum is less than target. My array is sorted, my sum is less than target. That means I need a greater element. Where can I find a greater element? When I'll move my k in the forward direction. That means I'll be doing k plus plus. Simple. And else case will be when my sum is less than target. When my sum is greater than target. If array is sorted, my sum is greater than target. What do I need to do is I need to have a smaller element. I'll be moving my L backwards. That will be L minus minus. I think this should work fine. And yeah, like this should work fine. I should be returning answer from here. Let me just run this particular prompt statement and check whether we guys are able to get, yes, like test cases have been passed. I should submit it. Okay, okay, guys. Yes. Failed. Wrong answer. Thank you, man. Thank you. Like, what's the issue? It says expected is -2 -1 1 2 -2 -1 1 2 and -1 -1 1 1. Okay, I have stored, I don't know why I have stored this two times. Output is two times. Okay, okay, okay. Do I need to take care of something as well? Where did I okay, 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 plus plus answer dot pushback. Okay, 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 guys. Okay, okay. Mm-hmm. Exam is equals to 0, else if, okay, k plus plus L minus minus. Here is the case. Like here, what is happening is we are doing duplicates. Yeah, like okay, okay, I got this. Did I got it right or wrong? I think yeah, like I got it right. What is happening is, let's say my kth or lth element, I have increased k plus plus and decreased L minus minus. I have got the sum. But what if the next element of the kth index is the same of k, and the previous index of the lth element is the same as of lth index? Then in that case, I do need to skip those elements as well. Yeah, like here you can see minus 2 1 minus 1 1 2. The same thing has happened here. We were not able to skip kth and lth similar elements, indexed similar elements. So how we can do that is, I can add a comment here, removing duplicacy. Yeah, I please ignore the spelling. Okay. If okay, while my k is less than l and my nums of k is equals to nums of k minus minus, simply do a k plus plus, means I do not want a duplicacy. And if while my k is less than l and my nums of l is equals to nums of l plus 1, yeah, simply do l minus minus. I do not want that. Yeah, I think it should work fine. Let me copy this particular, like, oh, nice, nice, nice. It has added it. Very good lead code. I'm impressed. I'm impressed from this feature. Okay, it is now working fine. We are expecting the same result. So yeah, like guys, these are the things that you need to take care of. Sometimes you forget some of the edge cases, and you need to figure out, oh, why this is not working. What did I did wrong? That is called problem statement, problem solving, and that is how we guys evolve. Yeah. Let me know if you have any questions, and please keep smiling, and please have that uh, happy thing in your mind that this question is just for some. Okay, and please go through the threesome problem statement as well. It is nice. Going through the problem statement threesome is nice, uh, and doing that is not nice. Okay, guys, see you then. Bye bye. Take care. No offense.